Hi, in this video I will explain how I made a rhythm game gameplay loop in Godot within just 2 days, and I will also talk about some important topics like latency removal. So in case you are interested in applying rhythm elements to your game, stick around for the good stuff. So let's start by looking at how my beat charts look like. So in LMMS digital audio workstation software, I have named MIDI tracks for each enemy and visual effects separately. I chose MIDI files as my beat charts for a simple reason. There is a nice Godot plugin called Godot MIDI, which has nice features such as playing a music file in parallel with a MIDI file and having function calls for each played MIDI note. For the enemy spawning in Godot, I first wrote a function which subtracts a value from all the enemy MIDI timestamps. To be precise, this time value is equivalent to the time it takes for an enemy to move from a spawning point to the hit point. Now during the enemy spawning, I assign a timestamp for each enemy, which represents the optimal hit time. Then later in player script, whenever player tries to hit an enemy, I calculate the difference of the current time and the enemy time, and if the difference is less than say 15 milliseconds, the hit is registered as perfect. For the perfect, good and missed hits, I chose these timing bounds based on a Reddit post with data from other rhythm games. Next to enemies, I used MIDI notes to trigger visual effects, and in contrast to enemies, the timing of these notes doesn't need to be adjusted because the visual effects will be triggered immediately. The organization of the MIDI notes in my game is quite simple. I have 4 lanes, so just randomly I chose B4 note bits to be the first lane, C5 to be the second lane, and so on. An exception to this in the game is the so-called metronome mode, where the enemies are moving in discrete steps along with the beat. To enable this mode, I simply subtract an octave of the original note data. Also sometimes I give the player an option to make 2 hits in parallel with this ghost character, and this is triggered simply with an additional MIDI note in a separate MIDI track. So this is all quite simple to implement, and I think it took me really only a single weekend to get these things going. The only downside with the MIDI approach, in my opinion, is that editing note data manually in LMMS is somewhat cumbersome, and I often made some mistakes by putting wrong notes with wrong timing. One very important thing to realize is that the time at which the user hits a key and the optimal hit time given by the MIDI player are usually not the same. And by saying not the same, I mean the player will get the sensation of being too early or too late, as the enemies are not exactly at the hit point during the beat. To understand this better, let's try to understand what's going on in a PC when a user plays a rhythm game. So in the simplest setting, some graphics are shown on the screen, a music score is played over the headphones or speakers, and a player must hit keys in a correct time. Simple enough. But then let's see what happens during one hit. When the enemy is in the perfect hit position, the sound data for the corresponding beat is sent to a data buffer, and this buffer is converted into sound in the sound card, and at some point the player hears the beat and presses a hit key. The key press is processed in Godot and we get the timestamp which we can compare with the perfect hit time. But now, because all these steps take tiny bit of time, the player key hit timestamp is always some milliseconds in the past. In Godot project settings we can combat this by adjusting the sound interface settings accordingly. But to get rid of this problem entirely, we need to compensate for the delay, or as it's usually called, latency. I did this by adding a simple calibration scene where the player should just hit any key to the metronome sound. After some 10 registered key hits, I can then calculate the average difference between the time that metronome sounds were played and the times the player was hitting a key. This average time difference is later subtracted from the perfect enemy time during enemy spawning. Alright, so now we get to some really cool nerdy stuff. As I'm not that good in rhythm games, I wasn't able to tell if the non-perfect hit accuracies were because of my lacking competence or because of a faulty implementation. To rule the former out of the equation, I built a simple rhythm game robot, which is really nothing else than a microcontroller with an analog signal input and a serial port output. So when the sound level at the microcontroller rises beyond a certain threshold, a serial port output is being generated. The serial port is then monitored at the PC, and for each serial port input a fake key press is generated in Python. And this way I was able to generate perfect hits every time. But what I found out with this setup was a bit surprising. In my Python script, registering the virtual key hits, I was always measuring perfectly constant timing between the beats. However, when I did the same in Godot, my measurements had some weird small outliers of few milliseconds every now and then. After some investigation, I was able to tell why. To my understanding, this is connected to how Godot registers key inputs. When we look at this Godot source code, we will figure out that pretty much all important engine updates like graphics, sound and input are running in serial. And since the engine updates usually 60 frames per second, there is a slight delay between the key press registration in the operating system and in Godot. So to avoid added latency because of this, our best bet is to disable the VSync and increase the FPS cap in project settings to say 150 and 200. Of course, in some games played by some players with possibly weaker PCs, increasing FPS cap like this doesn't guarantee a maximum FPS, so alternative fixes to this issue would be welcome. Alright, thanks for watching. If this was helpful to you, give some thumbs up and see you in a follow-up video, whatever that might be. Take care.